Okay, now we will move to the next presenter. Okay, members of the Zoom, rainwater harvesting system also can be a beneficial source in agriculture industry. Our next presenter from UNIZA, Senior Dr. Azimah Binti Ismail, has done a research on assessment of chemical properties in low-cost rainwater harvesting system for agriculture. To know more about it, I would like to welcome Senior Dr. Azimah to share her research. Please welcome.
Saya nak tanya yang tu tadi tu. Saya mesti ada nak tanya sebab sudah headset, earphone. Headset dan phone. Mana ada nak buat je tu? Tapi kalau anak guna tak boleh tu. Okay? On lah.
Oh my God. Sorry, hold on. My God. Okay, sorry for the interruption. Okay, Assalamualaikum and good afternoon. And then my name is Azimah Binti Ismail from East Coast Environmental Research Institute, Universiti Sultan Zainal Abidin. Thank you to the chairman and the rest. Okay, the topic of my paper today is the assessment of chemical properties in low-cost rainwater system for agricultural. Okay, as we know that the rainwater harvesting in Malaysia made an interesting among researchers since the Malaysian government has launched an RWH policy. And the rainwater harvesting system also, it was considered as the best management practice in Malaysia, because this one is the one of the alternatives, the water source in Malaysia that we can, can be utilized in the future. So the rainwater relatively clean, but can be contaminated as well by the presence of atmospheric pollutants, overhanging foliage, and bird debris as well. So therefore, the quality of rainwater harvesting should be analyzed before it can be used for any purposes. Okay, so my research basically the data collection I collected data, this is the secondary data I collected from the Meteorological Department of Malaysia. And then the data is covering the period of 3 years from starting from 2017 to 2019, from 18 rate gauge stations from for the entire area of Peninsular Malaysia. So the methodology, all the rainfall data collected from the Malaysian Meteorological Department were pre-treated for subsequent statistical analysis. So a total of 30,498 data points, which is content of 23 variables times 1,326 data set, were utilized in this analysis. So all the statistical computation using the Excel 2018 and the SL, as well as the SL stat in software. So here in my research, I used the multivariate technique, which is I ran the principal component analysis for analyzing the rainfall data set, which was performed through the I performed throughout this research. So here, the principal component analysis. So I use this as the formula for my statistical analysis. And then the PCA was applied on the 23 physical, chemical, and metal variable, which is such as ammonium, calcium, magnesium, calcium, nitrogen, and etc. So to identify the latent factor which contributing to the existing these parameters in the rainfall data. So here, after I ran the analysis, I use the PCA. So this is the result discussion. So from the PCA, I've got 8 principal component analysis. The principal component analysis is the latent variable, which is run the analysis during the when we want to determine the most factor loadings which is polluting to the rainwater in the rainwater harvesting storage. Okay. Through the analysis, I've got the principal component analysis 1, revealed the greatest amount of variance with a total variance of 23.84%, loaded positively with magnesium, nitrogen, chlorine, and the electrical conductivity, which is, this one is characterized by 4 variables loading on a single factor and 1 variable simultaneously loads in factor 2. So this chemical was generated from natural and anthropogenic aerosols. So the natural aerosols were mostly salt, dust, and marine aerosols, while the anthropogenic aerosol emitted from the agriculture and industrial activities, which is including the vehicle exhausted, road dust, and biomass burning. So while the principal component 2 was responsible for 10.81% of the total physical, chemical, and metal parameters variation, and has the highest number of variable loading on a single factor. So the variable were ammonium, calcium, nitrate, sulfate, nickel, and electrical conductivity. So there was strong correlation between ammonium and nitrate and sulfate in the atmosphere, which were originated from the ammonium. So the emission of NH3 positive into the atmosphere has increased due to anthropogenic activities. So while the PC3 with a total variance of 9.24% received the high loadings from carboxylic acid and moderate loading on CH4 and the carboxylic acid as well. So the PC4 accounts for 6.79% of the variance in the rainfall data. It was characterized by mineral ions and metals. Zinc loads 0.52 of factor loadings. So this is the system, the rainwater harvesting system that we have constructed at the East Coast Environmental Research Institute, or ISRI. So there are 4 numbers of high density polyethylene used to store the collected rainwater, and then the chemical properties of the harvested rainwater are assessed using the multivariate analysis of the PCA before further using it for agricultural purpose. So these are the agriculture that we use the rainwater harvesting. Yeah, this is the storage. It's not only for the papaya trees, but then this one is I use it for the vertical plant as well. This one. So as the conclusion here, so the implementation of the rainwater harvesting system in Peninsular Malaysia in Peninsular Malaysia actually is practically reliable and efficient at most of the local and urban regions. And through the research as well, the emission of the physical, chemical, and mental parameters in the environment found to be varied from multi-source factors, which including both natural and anthropogenic activities. So based on this study, the RHS can be implemented in small and larger scales due to the characteristic of rainwater in Peninsular Malaysia, which is suitable to be harvested for direct use of the potable water and also for the non-potable water as well. So this is okay. So that's the end of my presentation. Thank you so much.
Okay, thank you so much, Dr. Azimah. One remarkable research from Universiti Azimah. It's very interesting to see how the rainwater harvesting system being used in the agriculture section. Okay, maybe we have some questions from the Zoom.
Dr. Azimah.
Yes, Dr. Prof.
You did mention in your slide 9, if I'm not mistaken.
Yeah.
You mentioned that sulfate originate from the emission of ammonium.
Yeah.
Can you explain further?
Okay, like this, Prof. Okay. Actually, I used the secondary data from the meteorology. Is that clear, Prof?
Go ahead.
Yeah. Okay. I've got the data from the metro department, so which is considered as a secondary data. So from the secondary data, which is covers for 3 years from 2017 to 2019. So I ran the analysis. I used the principal component analysis or the multivariate analysis. So from the analysis, I've got 23 the most significant factor loadings. So from the 23, okay, I ran this. I've got what are the most factor loadings which is contributing to the pollution in the rainwater harvesting in Peninsular Malaysia.
Okay, I understand that, but sulfate and ammonium are two different chemicals.
Yeah.
When you mentioned that sulfate originate from the emission of ammonium, I feel something is not right there.
Because the sulfate is, I'm not, maybe I was mistakenly mentioned that, but then the sulfate, the ammonium, is more generated from the industrial activities and then from all the anthropogenic factors.
Okay, if that's the case, then that's right. Okay, all right, thank you.
Sorry.
Okay, thank you so much, Dr. Mizi, for very good questions. And also, thank you so much.
I got one question for you.
Okay.
Early on, you mentioned
now,
about...
without wasting any time. Oh, sorry.
Okay. Early on, you mentioned about your data from the meteorological department, yeah? That means open air. But the last part you mentioned, I saw the picture, you collect from the roof. Because otherwise, how to collect? So I believe you have to qualify yourself, the roof material. Because the roof material, if it's a brand new zinc or whatever, because it will impact open air. I believe if I open my mouth during rain, if I drink the water, I think it's very, very safe, yeah? Yeah, in heavy rain. But if it reach a roof, if I open my mouth and we drink the water, I'm very worried because the roof would have first the roof surface and so on. So I think there should be a distinction between the two. Because The analysis should be based on extra parameter. One is atmospheric, one is landed, because you mentioned earlier on. So just my comment, since I am listening to your presentation. Good one, good presentation.
Okay, thank you, bro. Thank you so much.
Okay. Thank you, Mr. Gary and Mr. Azimah.